Okay, I had a request for a video on angles of elevation and depression. So obviously, here I am. I'm going to do a quick video on that. So I'll start with a few things about angles of elevation and depression, and then I'll do two examples using that. So to start with, when we are talking about our angle of elevation, we're going from the horizontal. So if we are looking up at something, we are looking up at an angle of elevation, and so our line of sight is at the angle of elevation that we've been given. So we're looking at between the horizontal and the line of sight. If we've got an angle of depression, we're looking down at something, and so we're going from the horizontal down to that line of sight. So a couple of classic examples of when you'll be asked to do the angle of elevation, you might be looking up at the top of a building or a tower or a flagpole, etc. So you're looking up at something at that angle of elevation, and you might be wanting to find the distance across the ground or the height of the tower, etc. The other option might be if you're looking up at a plane in the sky or something else in the sky like a kite or a hot air balloon, etc., and you're looking up at that. When you've got your angles of depression, you're looking down at something. So you might be looking down at a boat from a cliff, which is a pretty classic type that you might see. The other thing, you might be a plane in the sky looking at something on the ground. So you're looking down at something. With our angles of elevation, we're looking up at something. So I've got two examples to look at with those types of questions. So the first one is an angle of elevation question, and a pretty classic type of that one. So we've got a person is standing 50 metres from the base of a tower. They see the top of the tower at an angle of elevation of 70 degrees. How tall is the tower? So I've just underlined those key pieces of information there. So when we draw our sketch, we're going to have our horizontal line for the ground. We're going to have a tower that they can look at. And we know that that tower is 50 metres, the person is standing. So we know that the distance along the ground is 50 metres. They are looking up at that tower, and they're looking up at an angle of 70 degrees. Now we don't have to measure those angles, we're just drawing a diagram. And we lastly want to fill in what do we want to know. We want to know how tall it is, so we put our X there. The next thing I always get my classes to do is label our triangle. So we're always labeling in relation to the angle. So here's our angle here, so we label with adjacent, opposite, and hypotenuse. I then get them to circle the ones that have something with it. So my adjacent has the 50, my opposite has the X. That tells me I'm going to use the tan ratio. So I'll write tan theta equals opposite over adjacent. I'll then pop in what I know. So I've got tan 70 is equal to X over 50. Now the 50 is on the bottom, so that means I'm going to multiply to get what the X is. 50 tan 70 equals X. Always making sure that your calculator is in degrees. If you're not sure how to do that, I have got a video on how to change the mode on your calculator. So we're going to pop in 50 times tan of 70, and we get 137.37. Now remember, on these kind of questions that we've been given a worded question, so we need to write a worded answer. So we would write the tower is 137.37 metres tall. Now obviously that is a very, very, very tall tower, but we did have a very big angle of elevation that we were looking at. In the next one we have our example of an angle of depression type question. So we have a person is standing on a cliff 80 metres high and sees a boat at an angle of, and that should be depression, of 15 degrees. How far from the base of the cliff is the boat? So we've got our person on the cliff. They're looking down at a boat in the water. And we know that the cliff is 80 metres high. We know that this angle of depression here is 15 degrees. Now this is the part in the question where you can go a variety of ways. So I often teach my students to look at the Z rule here and know that this angle down here is 15 degrees as well. Another option is to know that this one here is going to be 75 degrees. Now we want the distance from the base of the cliff to the boat. So this triangle is probably the easiest one to work with, or you could have put a dotted line up here and worked with this triangle. All of those options will work. I'm just going with this one for this particular question. So I'll put in my right angle, I've got my X, I've got my 80, I've got the angle that I'm working with, so I can then label that this one is my adjacent, this one is my opposite, and this is my hypotenuse. So I circle what I know, and then I write that that is going to be tan. So I'll have tan theta equals opposite over adjacent. I'll then put in the values that I have. So tan of 15 is going to equal 80 over x. Now in this case, my x is on the bottom, so I need to make them switch sides. So I'll write that x is equal to 80 over tan 15. Then I'll grab my calculator. I will do my 80 divided by tan of 15, and I get 298.56. So I'll then write my sentence answer there. The boat is 298.56 meters from the base of the cliff. So always remembering to put your sentence answer at the end. Make sure you're labeling your triangle, writing your working out with what ratio that you're using, and just being careful where you're putting that angle. That's probably the key thing with these questions, is where you are putting that angle in your diagram. Hopefully that helps. If that video helped you, please give us a like and subscribe to the channel.